Okay, I didn't really do much preparation for this, but I kind of feel a bit sick, so I'm gonna try my best to power through these questions. So hi, my name is Gabriel, and today we're back with another tutorial question that I realized a few of my friends didn't know how to do. And this question actually hits a bit close to home because I had to do it before, and I also didn't know how to do. So when my teacher went through and explained, I found his words of wisdom very useful, and I hope to be able to pass down his words of wisdom to you guys. So starting off, find 2 over r times r minus 2 in terms of partial fractions. So I would hope that you guys remember how to do partial fractions, because if not, please drop out of JC and go back to O levels. So an equation, this expression can be written as this. By cover up rule, when r equals to 0, 2 over 0 minus 2 equals to a. Therefore, a equals to negative 1. Then, yet again by cover up rule, when r equals to 2, 2 over 2 equals to b. Therefore, b equals to 1. So, 2 over r minus 2 equals to 1 over r minus 2 plus, 1 minus r. So if you do your cross multiplication, you realize that this will all work out to be whatever values you want. So okay, having this in mind, now let's go on to part 2 of this question. Find the summation from r equals to 3 to n of 1 over r minus 2. So to start off, right, personally, I really dislike writing coefficients when I do, like, let's say integration or summation notation. So I normally just do the original one, then apply the coefficients after that. So the summation from r equals to 3 to n of 2 r minus 2 equals to the summation from r equals to 3 of n of bracket 1 r minus 2 minus 1 over r. Alright? And then you realize that this is in the form of summation of r equals to 3 to n of fr minus 2 minus fr, where fr is 1 over r. Doing your MOD, you will get f1 minus f3 plus f2 minus f4 plus f3 minus f5 plus fn minus 3 minus fn minus 1 plus fn minus 2 minus fn. And then as you see by your telescoping series, these things will cancel out, and these things will also cancel out. So then you go back here, you have f1 plus f2 minus fn minus 1 minus fn, which is equals to 1 over 1 plus 1 over 2 minus 1 over n minus 1 minus 1 over n, which is equals to, oops, my math kind of sucks now. 3 over 2 minus 1 n minus 1 minus 1 over n. So now, this isn't really what we want. What we want, right, is half of this thing. So now, Therefore, half summation of r equals 3 to n of 1 r equals to half of that. 3 over 2 minus 1. Oh no, it's the light covering up, not yet. Which equals to 3 over 4 minus half n minus 1 minus 2n. Okay, yeah, supposed to be fraction, so over 2n over 2n minus 1. But I hope you guys get the point. So now, on to part 3 is the part that all my friends have problems with, and is actually the main focus of the video. I got tricked by it also. Actually, I didn't even get tricked by it. I just didn't know how to do it. So hence, proof summation n equals to 1. R equals 1 to n of 1 over r squared is less than 2. This is where something very beautiful happens. I want you to consider this. So consider that r squared is more than r minus 2 when r is a natural number and when r is more than or equals to 3. I want you to process this, because in the end, summation and sequences and series is just like functions, but they take integer inputs, i.e. x values. So logically, if you sum r squared from r equals to 3 to even 3 itself, it will be more, maybe to an n, okay? It will be more than the summation from r equals to 3 to n of this, for the condition such that n is a natural number and n is more than or equals to 3. Thinking logically, what summation really is that you're adding up the y values of like a given function and trying to figure out what happens when you add up all the y values. So I hope this makes sense. So consider that when you take the reciprocal of these things, so 1 over r squared is actually less than 1 over r minus 2, for r is a natural number, which is more than or equals to 3. I want you to consider this very important thing. So now, let's rewrite this. Is less than this. This is the most important thing in your answer. Establishing this rule is how you complete the question. So, the summation, hold on. The summation of this thing is equals to 1 over 1 squared plus 1 over 2 squared plus r equals to 3 and 1 r squared. Alright? Because you're just taking out the two integer r values. Hold on, let me just write the condition that I had just now for your 1 over r squared less than n summation times 3 1 over r minus 2. So please keep this in mind. And as you realize that this is always less than or equal to this when n is a natural number that is more than or equals to 3. So this condition applies now, and we can sub it in. Which is less than. Oops, sorry, brain fart. 5/4 plus summation r equals to 3 and 1/r minus 2. And now, using the thing that we got in part 2 is equals to 5/4 plus 3/4 minus 1/2. I think it's n minus 2 or 1 if I recall correctly. I don't really recall. Minus 2n. No, I think this is n minus 1. And it's equal to 2 minus this thing, the whole thing. And you realize that no matter what n value you substitute, that is not infinity, this thing will always be less than or equal to 0 with the condition that n is more than or equal to 3. So, since 5/4 plus is less than 2, therefore ta-da! The light is not blocking anything. That's wonderful. So yeah, my working steps are a bit unclear due to me having being constrained by my board and the handwriting. But you should have the whatever arguments I've written down just now before I erase them, then start off this step and do all this. So yeah, I hope that you guys enjoyed watching this short video because I definitely had fun making it. And I think my only problem is that I think this might be wrong. Everything else should be okay, but yeah, I hope that you guys can help your friends with doing this and that you learn something new. I dedicate this video to Alyssa, Amos, and Linus because those were the 3 jokers that kept asking me to explain this. And yeah, I also dedicate this to my friends in 2113 because I want y'all to impress your teacher. Hopefully I don't have to make any more of these videos. See y'all next time.